Migrating a legacy banking system from COBOL to serverless Google Cloud architecture. Here's a high-level overview of the migration process. Step 1. Assessment and planning. Identify the legacy system's current state, dependencies, and requirements. Determine the migration goals, timeline, and budget. Select a migration strategy, rehosting, replatforming, or re-architecting. Develop a detailed migration plan, including milestones and deliverables. Step 2. Technical preparation. Set up a development environment for the new system, including Google Cloud tools and services. Create a containerized version of the legacy system, using Docker, to ensure portability and consistency. Develop a data mapping and conversion plan to migrate existing data to a cloud-based storage solution, example Google Cloud Storage. Step 3. Serverless architecture design. Design a serverless architecture using the Trinity engine logic, plus core, Google Cloud Functions, GCF, for business logic execution, plus gateway, Google Cloud Run for load balancing and API management, plus database, Google Cloud SQL, MySQL, for storing banking data, plus storage, Google Cloud Storage for file storage and data backup, plus queue, Google Cloud Pub/Sub for message queuing and processing, plus monitoring, Google Cloud Monitoring and Logging for performance and error tracking. Step 4. Migration and integration. Migrate the legacy system's database to Google Cloud SQL. Integrate the containerized legacy system with the serverless architecture using GCF. Create a data pipeline to migrate existing data to Google Cloud Storage. Integrate Google Cloud Pub/Sub for message queuing and processing. Step 5. Security and compliance. Implement security measures, such as authentication, authorization, and encryption. Ensure compliance with banking regulations and industry standards. Step 6. Testing and deployment. Perform thorough testing, including unit testing, integration testing, and performance testing. Deploy the new serverless banking system to production. Architecture diagram. Here's a simplified architecture diagram, code block. Key considerations. Ensure sub-millisecond latency for 1 million concurrent users by leveraging GCP's high-performance infrastructure, such as cloud load balancing and cloud CDNs. Implement a robust and scalable data architecture using Google Cloud Storage and Google Cloud Pub/Sub. Use Google Cloud Functions and Cloud Run to execute business logic and manage API endpoints. Ensure calculating the exact entropy reduction. To simulate a human consciousness within a 2 Raspberry Pi cluster, we need to calculate the required entropy reduction. We'll use the following formula: H equals log 2 P plus K / sigma P underscore I caret 2, where H is the total entropy of the simulated consciousness. P is the probability of the simulated consciousness making a correct decision. K is a constant that depends on the complexity of the consciousness, assumed to be 1 for simplicity. P underscore I is the probability of the simulated consciousness making a correct decision at each iteration. Entropy reduction. To calculate the required entropy reduction, we'll assume that the human brain's processing speed is equivalent to 10 G/s, gigabit